Hey, welcome to lesson 4.3, proving triangles are similar. Now this is just like what we did with congruent triangles when we proved they're congruent. We're going to do the same thing with similarity. Now the first thing you should know that there are three ways. There are three ways to prove that triangles are similar. The first one is called angle-angle. The second one is called side-side-side. And the third one is called side-angle-side. And you will learn about all three today. So let's get into it. Alright, the first one we're going to learn about is angle-angle similarity. Now we know that this is true. Triangles are similar, alright, if two angles from one triangle are congruent to two angles in another triangle. So if we look in these two triangles right now, we see that B is congruent to C and A is congruent to Y. Because two of the angles are congruent to each other, we know that these are similar triangles. So just like we did with our proofs, we're going to write out our evidence. So triangle B is congruent to angle Z, and angle A is congruent to angle Y. Because we have these two angles that are congruent to each other, we know that triangle ABC is similar to triangle YZX. And the reason I took a second there is because remember, you have to make sure that you put things in the right order. A has to go with Y, B has to go with Z, and C has to go with X. Remember, the corresponding sides in the order, A and Y are congruent. Alright, and the reason we know this is because of angle-angle similarity. Alright, if there's two angles, then we know that the two triangles are similar to each other. Alright, so in this case, we're looking at triangle ACT and ULV. And we see that A is congruent to U because they have the same measure of 30 degrees. And we see that C is congruent to L because they also have the same measure of 110 degrees. So we have two congruent angles. Now remember, if there's two congruent angles, then we know that they are similar triangles. So let's write out our evidence. So angle A is congruent to angle U. Angle C is congruent to angle L. And now that I have two angles that are congruent, I've provided just two angles, that's my evidence. I know that triangle ACT is similar to triangle ULV, and that's because of angle-angle similarity. Now let's check out this guy right here. Now you might be looking at those and be like, okay, well B is congruent to E, there's one angle that's congruent, but 40 and 60 are not congruent, so this is not similar triangles. But you always have to find the third missing angle to be sure. Alright, so let's find our third missing angle. So remember, all we have to do is do 180 minus 80 minus 60. And when I do that, I get 40 degrees. Whoa! And I could do the same thing on this side too. So 180 minus 80 minus 40, this is how I find my missing angle, and that gives me 60 degrees. So now I know that I have at least two congruent angles. So I got 60 right here, and I got 60 right here. So now I have two angles that are congruent, and I can write out my evidence. So angle B is congruent to angle E. Angle A, which is 60 degrees, is congruent to angle F, which is also 60. And because I have two angles that are congruent, I know that triangle ABC is similar to triangle DEF. Or, sorry, watch out, don't do what I just did. It has to be in the right order. Whoa, be smart about this. A is congruent to F, so F has to go first. B is congruent to E, so that has to go second. And then D is congruent to C. And why? Because of angle-angle similarity. Alright, let's move on to the second way to prove similarity. This is called side-side-side similarity. Now, if all three pairs of corresponding sides of two triangles have the same ratio, then the two triangles are similar. This is a lot like we learned in the last lesson. If all three sides have the same ratio, from bigger to smaller, then we know that the triangles are similar. But that has to be the same for each one, or else it's not a similar triangle. Okay? So if you ever want to prove this similarity, you have to write out all these ratios to check that they're the same. You always have to check it. Don't just assume. Okay? So let's start with our first one. Our first one is YX and YZ and EF. So YZ is 10, that's our bigger triangle, and EF is our smaller, so we're going to put 5. YZ to EF, 10 divided by 5 is 2. XY, that corresponds to GE, so XY is 8. Let's use same colors here. GE is 4. 8 divided by 4, also 2. And then we have XZ to GF. XZ is 4. GF is 2. 4 divided by 2 is 2. Since these ratios, after I simplify, and remember, always simplify your fractions, then you know, since they're all the same, that they are similar because of side-side-side similarity. So let's say this. So triangle YXZ is similar to triangle EGF because of side-side-side similarity. Now you always have to write your evidence first and then your conclusion if you're ever proving that triangles are similar. Alright? You always have to have that there. Okay, so we want to prove triangle CBA is similar to triangle EFD. To do this, let's check out our corresponding sides. We know we have 3 sides here, and we know that CB corresponds to EF because the order is the same. So CB to EF, let's see, CB is 16, EF is 12. Our next one is BA corresponds to FD. So BA corresponds to FD. BA is 12 and FD is 9. And then finally we have CA corresponds to ED. So CA is 8. So CA is 8 and ED is 6. Now if you're looking here, you'd say, oh, well, the ratios are all different, so these aren't similar. But wait, what did we forget to do? That's right, we forgot to simplify. We need to always simplify. And let's see if this works now. 16 over 12, well, that reduces to 4 over 3. 4 over 3. 12 over 9, well, guess what? That also reduces to 4 over 3. And 8 over 6 also reduces to 4 over 3. So since my ratios are all the same, all right, these are all the same, they are equal to each other, we know that these two triangles are similar. So we could say that triangle CBA is similar to triangle EFD because of side-side-side similarity. All right, for our final one, it's side-angle side similarity. And the way this works is as follows. If two sides in one triangle are proportional to two sides in another triangle, and the included angle in both are congruent, then the two triangles are similar. So it's saying that if the ratio of two sides with an angle in the middle, just like when we had side angle side before, are congruent, then that is side angle side similarity. And let's check this out. Let's see how this works, okay? So we're going to start off with this. We're going to write our first ratio, which is CB over YZ. Those are the two bigger sides. So the bigger side is CB over YZ, all right, which is 36 over 24. All right, and that reduces to 3/2. I know I have a congruent angle. B is congruent to Z. Why? Because they're both 90 degrees, so they must be congruent each other. And then finally, I know that BA and YZ correspond to each other. So BA over YZ is 15 over 10, which once again reduces to 3/2. Now, since the ratio of two of them are the same, and there's one angle in the middle, and this always has to be in the middle, just like in side angle side for congruence. See how that's in the middle? The angle's in the middle. Has to be in the middle for both of them. It's in the middle, and it's in the middle of the two sides. Well, then we know that these two triangles are similar. So this, we can say that triangle ABC is similar to triangle XYZ because of side angle side similarity. Now we're going to prove that triangle ABE is similar to triangle CBD, and we haven't been given any of that fill-in space, so we have to do it ourselves. So let's first by listing our evidence. That's where we start. Let's write out our evidence. Okay? So our evidence, well, this looks like it's going to be side angle side because we have two sides, And remember that vertical angles are always congruent. So these angles are congruent to each other, so it's side angle side. But it's not a conclusion yet. We can't just say, oh, this is side angle side, so they're similar. No, we got to check some ratios first. So let's first start checking some ratios. We see that AB and CB should correspond to each other. So AB over CB, let's check that ratio. That is equal to 48 over 36, which reduces to 4/3. Always simplifying, right? What is that? 4/3. Well, now we need an angle, and we know that angle ABE is congruent to angle CBD. All right. Remember, vertical angles are always congruent, so we know those are the same. And then finally, we know that BE corresponds to BD. So BE corresponds to BD. Those are, and that would be 16 over 12, which gives us 4/3. So now that we have our two ratios, we see that 4/3 and 4/3, the ratios are the same, and when these two angles are the same, we can now write our conclusion. So our conclusion is triangle ABE is similar to triangle CBD, and that's because I don't have enough room, side angle, side similarity. All right, great work here. Now remember, you always have to write out all your evidence. If you're not writing out your evidence, you're not doing it right. Now this is our final one. All right, we're going to prove if these triangles are congruent. But, I mean, not congruent, similar. Duh, that's what this lesson's about. Now you might go around and you might start saying, okay, well, XZ and AC correspond, and XY and BA, and writing out your proof. But before we write the proof, you could actually say that these are not similar. And how do I know that? Well, because the angle has to be in the middle of the two sides in both of them. And if you look here, let's use our old trusty highlighter again. In this case, the angle's in the middle of the two sides. But in this case, the angle is not in the middle. Oh. See, our angle is not in the middle. Angle not in middle. So, since it is not side angle side, it is not similar. All right, the angle always has to be in the middle of both of them. Don't get tricked. All right, that's it for this lesson. Go home and tell your mom you're going to grow up to be a doctor so you can buy her a nice house, or a lawyer, or an engineer, or anything you want to be. Peace.